Good morning, everybody. It's a beautiful, cool, cloudy, rainy day in western South Dakota today. And over the past couple of months, if you've been watching the channel, you've seen me posting videos of my students as we're out in the field collecting samples as they've been working on the Black Hills Mine Legacy project for their senior design project. And then we looked at the sample preparation, had a little video on that, and then their work with the X-ray fluorescence machine to determine mineralogic composition of their samples. And today is on campus is the Senior Design Fair, where all the senior design projects from all the different engineering programs come together in one place, and they exhibit their results of their projects. And so I'm heading over to look at their project presentations. They're all posters. There'll be 5 of them, one from the design class last fall, and then the 4 teams that went out during this class that we filmed this year. So we're heading into the Surbeck Center, which is right here, and they're in the ballroom in there. We were supposed to be having a blizzard today, but it decided to go north, and so it's up in North Dakota. So they're getting the snow. We're getting just maybe a 1/10 of an inch of rain, so we're short on moisture. Okay, and here's one group right here. Lots of pretty pictures, but we don't have any idea what they mean.
Yeah, I can explain.
Okay, so let's take us through this real quick here.
Okay, so our main objective was trying to discover if the uranium contamination in North Cape Hills was from the mining back in like the 1950s. So we first started by mapping out the area and finding some old well logs and plotting them in GIS. And then we, based on those well logs, plotted the depths to the aquifers. So we approximated the 20 feet, 200 feet, 750 feet, and then we were able to map like a potential map of the North Cape Hills, just showing like approximate water levels. And then also based off the well logs, we were able to map some a hydraulic conductivity contour map of the area, and we're able to do some slug tests in Octisol to further conclude the hydraulic conductivity. And then based off all these models put together, we were able to estimate the velocity and the direction of the contamination. So this map right here is showing the Riley Pass mine, so where the contamination could have possibly come from. And this is showing the approximately like 68 years from 1954 to 2021, showing how far it got, and it only we approximated that it traveled 0.1 miles in that 68 years, and then we approximated that it would take 439 years to get to the closest well. So we concluded that there would be the contamination in the area did not come from the mining in the past. That it's probably from the just naturally occurring uranium in the area.
Okay. And you did this all by yourself?
We did it. We did it in groups of 2. There were 6 of us total, and each of us did it slightly differently, but we all came to the same conclusion. So Richard was in a different group with another partner, and I was in my own group, but we all came to about the same conclusion of it didn't spread very far over the 60-some years, and it concluded that didn't come from the mining.
So there you have it. So, radionuclides and heavy metal transport assessment, which turned out to be pretty low.
Well, but that's
which is actively a secret website determined by the EPA. So they're doing a bunch of remediation on it. And they want base levels of like 596 parts per million of arsenic. And this one is like over 1,000. So not that good.
Where are you going, VRC?
Yeah, you go for it.
Oh, you guys are in the dark over here.
Yeah, I know.
Get something pretty good here. Spins too fast or puts too much force on the you guys just Okay, so this one, environmental impacts of legacy mining in the southern Black Hills. So this was, I think, our first day in the field. So you can go back and look at those videos if you want to be refreshed. So why don't you guys take us through what we got here? So we got Wyatt, and we got Rainer, Richard is over manning the other person right now. That was the team here. So, what do we got?
So for our project, we were told to take a look at some local mine sites that have been decommissioned over the past century for possible heavy metal contaminants. We were in the southern Black Hills, so our site area pretty much consisted of Custer and outside of the Fall River Formation. Most of ours were more towards Custer, say like the White Elephant and May sites, Future Load as well, with our uranium pits being in the southwest of our site. From there, we developed SOPs to produce a safe and consistent way of sampling. From there, we went with Dr. Settler to go collect the samples. After that, after collecting both soil and rock samples, we took them through the crusher to get them down, be fine enough to work with the XRF machine. The XRF microscope that will analyze and count parts per million for up to 20 different elements, as well as an assortment of light elements. But the light elements would have skewed our data on the logarithmic scale, so we decided to normalize that with logarithmic scale.
Yeah. So after we put it through the XRF machine, we were pumped out with all of this kind of data about how many parts per million this certain type of element gives off. Some of the ones that we wanted to focus on that stuck out to us mostly were our arsenic concentration, lead concentration, and uranium concentration. The red lines that you see, the horizontal lines on each of these graphs, are the safe percentages or safe amounts of each of those concentrations. You can see that a lot of those are surpassing the safe quantity within our samples. We also have some curious chemicals coming up in some of our samples, such as cesium popped up in one of ours. We have potassium as well popping up in quite a number of our samples. Vanadium. We're looking at quite a number of radioactive chemicals here, as well as other heavy metals that are chemical contaminants that may be from our sample sites, from those mining processes.
Okay, so is there any major concerns that you can see?
Absolutely, right off the bat. I mean, like we said, this red horizontal line is the allowable amount, and since many of these surpass that, it is a contamination that is on the dangerous side.
So as far as you were able to determine, so you got arsenic, lead, and uranium that are all above the safe background levels. Were these introduced as part of the mining process, or were they naturally occurring?
A little bit of information on that. Arsenic has been used as like a wood treater for like a lot of old lumber. I actually have some experience living in Deadwood, South Dakota. I lived just above Whitewood Creek, where they would dump in cyanide that they'd use to treat gold and heap leach mounds. And our well water had arsenic and radon for a lot of the time I was there. But arsenic primarily, as I said, is used in it was used historically as a wood preservative, and most of these sites that had shafts and mines all had these wood supports, and a lot of that will leach out after a certain amount of time. Lead was actually pretty natural. There's galena deposits all over the Black Hills. It's very heavy metal. We also had information for nickel and mercury. Mercury is pretty naturally occurring. It has been used for some heap leaching, but I've even found mercury naturally in the hills while gold panning, just in the bottom of creeks. But nickel, yes. Nickel was above the safe threshold, but I believe the safe threshold for that was either around 83 or 400. And as you can see, for nickel, it would have exceeded that regardless if it were, But other than that, a lot of it would just be like hydrogen, which we didn't analyze. That was in our lighter elements.
Okay.
And I can tell you a little bit about these old uranium mines. So they were part of the DRUM program, part of the Department of Defense and Energy. They started it back in the day when there was that need for uranium. But what happened was they kind of decided they didn't really want it, so they kind of just scrapped it and just left it. And it's all on United States Forest Service land. And as far as we know, they have plans for reclamation, but nothing has really been done so far.
Okay. And which ones is that the one down way in the southwest?
Yeah, there's quite a bunch around Edgemont, but the one we did was
Lucky Bud.
yeah, Lucky Bud.
Lucky Bud.
The city was
Okay, yeah.
It was closest to Newcastle.
Okay.
Here was our highest sample of uranium ore. So this was from that Lucky Bud, which was one of the Edgemont mines, or the open pit uranium mines. So this has coronite in it, and I believe this showed up as 40 ppm for background radiation. But it's our hottest sample out of the entire thing. A lot of other sites, including sites that weren't located in that Fall River area, still showed up with a decent amount of vanadium, which was pretty standard across the board, so we didn't decide to analyze that individually. But a lot of other samples, most of it was plutonic rock, so it is likely that most of those radioactive elements are still in there and are just slowly becoming more stable.
Okay. All right. Thanks, guys.
Okay.
Okay. Actola and Mystic. So this was the day that these women showed me all kinds of new mine sites that I'd never seen before or ever been to before. So, okay, so what did you guys find?
Well, we found unhealthy levels of arsenic, lead, nickel, and cesium. We compared these levels to the background levels of soil outside the mine site, and then we compared what the healthy soil levels were according to CDC, EPA, other departments of health. So arsenic was really the big one at all of the mines, especially for where home load. It was our first sample was taken on top of a tailings pile. So tailings piles are notorious for producing large amounts of arsenic over time. So
That's this one up here?
yeah, so this was the arsenic, and you can see this is a safe level for soils. We also have our arsenic levels here by mine, and then we put the local background level from sites that were a distance away. And so you can see Jenny Gulch going off of a nearby, So the nearby background levels for arsenic were 12.8, but at Jenny Gulch it was 950 and 37 ppm. Home load was our worst one by far. So, and then
everything's significantly higher than the background.
Yeah, and Cuddy Sark had a really high amount of cesium, which we're guessing was possibly used in processing at some point, something along those lines. We're not really, we'd have to look more into it, but background levels were 0. Yeah.
Okay, so lead, 1 exceedance, cesium, 1 a bit above, nickel, 1 exceedance. Okay. No uranium?
We did not discover any high levels of uranium.
Okay.
Yeah.
But you did not sample any actual pegmatite, like granite, did you?
No, it's mostly...
And then like another thing is, you know, we did find really small traces of mercury, but they were far below, you know, it was only 10 ppm, whereas healthy levels were much higher.
Is that listed down here somewhere?
Yeah, so we have our mercury concentrate, It was really, we only had one site that had 10 ppm, which is perfectly normal.
Do you think that was part of the geochemistry of the site or introduced?
I think it's part of the geochemistry of the site.
Okay, very nice. So we could go out and walk around the hills without having any problems. All right. Potential contamination from legacy mining in the Black Hills, Western Pennington County. Okay. So this is all getting kind of fuzzy to me. You're going to have to remind me of where you went and what you did.
We went out Western Pennington County up by Rochford, a little bit north of Custer, a couple sites around there. Went out there, sampled some rocks, some soils here. Basically, we found 2 sites where we could attempt to establish some sort of relationship here. The one where we went up near Rochford, we went to the very top where the mine and the mill stamp was. The rock up at the top, which they used for actually building some of the buildings or left over from the buildings that are up there.
Okay. That's the one where we went in the snow and went up that hillside.
Up that winding hillside.
Okay.
And then this mine is one they went to on their own, I think the next weekend.
Okay, yeah, 'cause I don't remember seeing that.
Yeah, that's the one that we drove by in Keystone.
Oh, up the hill.
Yeah, up the hill.
Oh, right. Oh, wow, look at that. Okay, and that was like, what, 300-400 feet above the ground?
Yeah, it was quite a bit of vertical to get up there. But they had some open pits and they had the shaft. They had a vertical and the attic in there.
In front of it?
Yeah.
Any property signs, like who owns it or anything?
It's all on federal ground.
It's all federal.
Yeah. I couldn't see any active. Yeah. Yep.
Okay.
And up there we did have some arsenic both at the mill site and in the tailings pile.
Okay.
And you can see it kind of filter down as we move downstream.
Okay. And then what are these other ones? Sample number of...
Yeah, these are the compositions from
Okay, so arsenic, mercury, lead, nickel, and zinc showing there. Okay. And this is in a down slope direction? All of these is one right?
Yeah. This is our host rock, and that's for this map here.
Okay. So green is zinc. So decreasing down away from the site. That's interesting.
Lead as well.
And lead is
The gray one.
the gray.
So we compare the soil data to the NURE data.
Yep.
The lead levels are 9 times higher at the top here where the mine actually was. And when you actually get down to roughly the same elevation as where they took the NURE data, which is maybe like a half mile down that road, it's still 4 to 5 times higher than that soil. You see this nice kind of pattern as you go downgrade from the 9 times to 5 times to about that 4 times at the bottom.
So that was one of the things about that NURE is we had every 1 to 24,000 total map in western South Dakota already cataloged by, I think they listed by county. So if I knew I was going to be in Lawrence County, I'd go grab a half of those topo sheets. And they already have pre-selected locations on there where I found X, sample of X. So their sample location here was away from where the hottest samples were. So it was a real coarse type of data assessment. Made a lot of people mad. Okay, so any really issues or dangers that you found or uncovered?
The only thing that was really above concerning levels was our arsenic at both of these sites. And we did have one sample that had higher lead, but it still wasn't enough to really clear into a danger zone.
So you think that was naturally occurring or introduced by mining?
It was right at a mill site, so like the mining.
All right. So what's this?
This is looks like a printed topographic map of the project area.
3D map.
Yeah.
You didn't paint it?
Nope. And that should be Black Elk Peak here. This is western Pennington County.
Okay.
The mine with the lead that we were talking about is right up here off of that stream there. And then the where is it? The arsenic mine is over here.
Okay. That's really cool. Man, you can get all kinds of shade down here too.
Yeah, it's 5 times vertical exaggeration, so you actually get some sort of...
Yeah, awesome. Okay, this is the last day, I believe. We went up to the northern Black Hills, and this included the samples along Whitewood Creek north of, there it is, right there, it's the map. Okay, so I just got to keep straight where we're at here. Okay, so we have Sam and Chloe here today. And why don't you guys take us through what you did here?
Okay, so the historical mining activity in the northern Black Hills Whitewood Mining District, we have a map here. So this is a historical map of all the claims. So we put on the deposit types that would cause problems with mining. So this is a Carlin type disseminated gold deposit hosted in arsenic. That is homestake, hosted in arsenopyrite, and that is very similar to the Gilt Edge material, also hosted in arsenopyrite. So the main problem within the Northern Hills is that all of the gold is hosted within arsenopyrite. So basically within this survey, we looked at areas where we expected further contamination from legacy mining of these minerals. So we had a lot of spots down gradient and downstream from the areas, and we'd go out and we would sample contaminated and uncontaminated areas within the Northern Hills. So as a result of that, we had 6 locations that we broke down our areas into. Yates Shaft is right where that's the head frame for a homestake, one of them, and that would be mining that homestake ore. We have Whitewood Creek 1, and that's closer to town, and then Whitewood Creek 2, which is farther away, and that's those top spots, those pink spots. And then Lower Galena is down by Gilt Edge, and then Golden Reward is to the left over by Terry Peak, and then Gilt Edge is over to the right also by Lower Galena. So the 2 areas that we came back with the most contamination is Gilt Edge and Whitewood Creek. Gilt Edge was deemed a Superfund site, so we we sampled to see if they met their EPA regulations. Such regulations were 596 parts per million of arsenic and 134 parts per million of thallium. The thallium passed. They cleaned that completely. The arsenic for Gilt Edge, we had 2 samples that passed their remediation effort below about that line, and then we had one that was over 1,000 parts per million. That was slightly up gradient from the confluence of the creek that we're sampling, so it was a little bit of a surprise to see that. And then Whitewood Creek samples up at the top, those farther areas, all of Whitewood Creek was drained from Homestay put their tailings into Whitewood Creek, and it drained all the way up into those areas up there. So we took a bunch of samples there, and most of them came back with pretty high arsenic values. We had one that came back over 10,000 ppm of arsenic, which is not good. We had 6,000 ppm and then above 3,000 ppm, and those were from the tailings that were being generated from Homestake historically. And this is actually one of the bags of this would be really arsenic-rich soil that we ground up and scanned from XRF.
This was one that was collected along the creek?
Yep. Sample S0016 up at the top, right up there. So very interesting. So those ones, the goal for the remediation effort of Whitewood Creek has been less than 100 parts per million of arsenic. So they have some work to go on that one. They're definitely flying much hotter than they'd like to be. Do you have anything else you'd like to add?
Yeah, that was basically it.
What about the first sample we collected of the old slag? Did you analyze that one?
Yeah, so that was right here in the Yates shaft, and it's sitting.
Oh, okay.
Oh yeah, and the rocks down here.
Okay.
These,
so which one is it? The
these
triangle?
bottom,
Oh, it's really low.
The diamonds.
It's really clean.
Okay,
Which was surprising.
It was just really nasty looking black glossy junk, but it's not too bad. No gold in that?
Very small amounts.
We had, I was hoping for gold in there.
We had one of the tailings from Whitewood Creek up at the top had I want to say 42 grams per ton in it, which is really high.
Wow.
But we came to the conclusion that it was probably locked in really fine grained arsenic that they just couldn't process at the time. So we were pretty excited about it for a little bit, and then we realized that
Yeah, you never get permission to get back in there and disturb that stuff.
no. And even if you did, you would be, this rock, that's got gold in it too, but you're not getting any gold out of that.
Yeah.
Any questions?
All right. No, good job. Okay, so that's that. I hope the audio came through. A lot of conversation and talking in there. I tried to keep the mic pointed at the speakers, so I guess we'll see. So that's it for this project. Let me know your comments down below if you have any. As usual, thanks for watching, and see ya.